Okay, right. So everybody, the first academic lesson. You're all in the, I guess we could call the very first cohort of students that we have. So for me, this is super exciting. I know it's super exciting for Piero as well, one of our other teachers that you will meet later on in the course. And I just wanted to thank you all for being here as well, because what you are doing is making a commitment to improve, a commitment to change something in your life. So you should be really proud that you're even just making that first step. I'm imagining that over the course of what we're doing, there may be some students who drop off. I think that's natural, but I hope that as many of you as possible will stay with us for the duration of this course, because we want to make things better for you. We want to kind of give you new skills that you can potentially get a new job with and things like that. So anyway, look, there's loads for us to cover. Now, as some of you will know, the curriculum is geared towards web development and kind of software development, but using web technologies such as JavaScript. So where better to start than kind of figuring out how the web works. So let me just share the screen for the presentation that we have. And then I will start to talk about it. And one thing I have said as well, or I'd like to just mention again, is please be patient. Please be patient with me, with the other teachers, and just with the process at the moment, because as you know, we kind of started this initiative less than a month ago. And we're trying to push things as quick as possible so that we can teach you as quick as possible, or as soon as possible, I should say. So there might be some hiccups and bumps along the way, but hopefully we can tackle them as we go on. Right, okay, so let's bring up our presentation. So this was the screen that you all saw for a very long time earlier. Okay, so how the web works. Okay, so before I start, let me just take a sip of water. Okay, so we're going to tackle this question of how the web works by looking at three things. How do you create a website? How do you upload a website? And how do you visit a website? Now, I know some of those things are going to sound a little bit simple. And to be honest, it's kind of deliberate. I've deliberately made them sound very simple, but we're going to kind of deep dive into those with varying degrees, and you'll see what happens. During this, for anybody who has never kind of studied web development or is kind of new to the field, there might be some technical words or jargon that I will use. I'll do my best to explain them as I go on. But if there is anything that you would like me to kind of clarify, just make sure you use the chat functions kind of on Discord or immediately in this chat, just to type the question, and then I will look and try to answer them at the end. Okay, so how do you create a website? Well, just like with cooking, there are two fundamental things that we need: ingredients and tools. Now, if we take a look at the first, if we take a look at ingredients, there are three things we're going to need: HTML, CSS, and JavaScript. Now, let's take a moment to kind of talk about each of these. So, HTML. Well, a website is kind of just like an online document. For now, let's think of it as being a little bit like a Microsoft Word file or a Google Docs file. Now let's focus on an example for a moment, okay? Now the example here is a file full of text. Now, just like how you would use punctuation to split up text into sentences and paragraphs, HTML or hypertext markup language gives structure to the text in a document. So, for example, if we wanted to create a paragraph in a regular text document, we typically have a block of text, and we would create a space beneath it, maybe by pressing the Enter button on our keyboard a few times. In HTML, we take our block of text and we wrap it with some tags. Now, those tags are basically angled brackets that we place either side of our paragraph. Now, there's a specific type of paragraph that we would use for signaling that, and we've kind of what we've created here is a paragraph which we refer to as a P tag. So you'll see the kind of P tags that we see next to where the arrows are. One moment, I just need to mute whoever has just joined. Sorry about that. Yes, so as I was saying, with HTML tags, if we want to create paragraphs, we use P tags. We call that simply because the letter P sits inside of those angled brackets. Now, at the start of our paragraph, we would have an opening angled bracket, the letter P, and then the closing angled bracket. The reason why they're important is it enables our browsers to be able to then comprehend and understand what is regarded as a paragraph. And that's useful for us as readers and viewers, because the browser will present the document to you with the spaces that we would expect to see if we were reading paragraphs in a book, for example. If we didn't use those tags, we'd simply kind of created line breaks or something like that, then our browsers wouldn't pay attention to those spaces, and you'd basically kind of see the document as just one big block of text. By the way, those angled brackets and the P tag we were talking about a moment ago, what we can kind of consider to be known as syntax. And syntax simply just refers to language specific devices to convey certain things. So in linguistics, the punctuation that we use is syntax that conveys certain things. For example, if we used a full stop, it would signify to the reader that a sentence has ended. It also signifies that a short pause is required in reading. In the case of HTML and all other programming languages, the use of syntax conveys something to the browser, or better yet, to the computers. For example, if it sees two sets of P tags, it knows to distinguish those as separate blocks of text, and kind of, can therefore put a space between them. Okay, so we've got an idea of what HTML, what a HTML document is. So let's move on. Okay, so CSS. So a HTML document without any CSS will simply be presented to you on the screen with kind of whatever defaults your browser has determined. When we say browser, just for anyone not aware, we're kind of talking about things like Google Chrome, Firefox, Microsoft Edge, Internet Explorer, things like that. So as I was saying, a document without any CSS is just going to be presented to you on the screen with just kind of default styles. And you can expect it to look a bit similar to how a page in a book might look. We'd have a white background with black text. The font most likely will be kind of Times New Roman. And we may have levels of different size text determined by which HTML tag has been used for each block of text. And just like how we have paragraphs or P tags, there are different types of tags available to us as well, such as heading tags, of which we have 6 types, H1, H2, all the way up to H6. A H1 tag will typically be larger than a H2 tag. A H2 tag is larger than a H3 tag, and so on. And therefore, the browser's default presentation of your document is representative of that. Okay, so we've got an idea of, so while a browser will provide default styling, CSS allows us to not only override those defaults, but add completely new ones. So, if we wanted to change the color of text on our page, we'd use CSS to do that. If we wanted to increase the amount of space between paragraphs, we'd use CSS. Near enough anything you can think of in terms of ways that you can alter the appearance of a document can be achieved with CSS. And new features are being added to the specification all the time. And because of this, techniques that may have been used to style a website 20, 10, or even 5 years ago are likely to be different to the ones that we've used today. Because of this, it can be interesting to view or come across websites that haven't been updated for many years. Because while sometimes there may be, this may be due to the look and feel of that time, but it's also due to the limitations or possibilities of styling with CSS at that moment. Okay, so I'll just take a moment to pause. I just want to make sure, can everybody kind of see the screen? Can everybody hear me okay? Anyone kind of just respond in any of the chats so that I'm aware? Okay, amazing. It sounds like you can all hear me okay. I've got loads of yeses. That's amazing. Sorry if I'm kind of sounding a little bit thrown off at times. It was probably due to whoever stopped the recording earlier. Please don't do that because it's super frustrating. Okay, so we've kind of touched on HTML and CSS. Let's have a look at JavaScript. So the third ingredient, as we said, is JavaScript. And this is typically what we would use for handling user interaction. When we say user interaction, we're kind of using that term very broadly to almost cover all sorts of things. Okay, so such as handling mouse movement or touch gestures, to handling a website sign-up form, maybe validating an input field to make sure that your password contains the right amount of characters and even the right type of characters. Handling a shopping cart on an e-commerce website. And keeping track of what items you've added into it, as well as calculating the total with and without shipping, to processing what happens when you like a photo on Instagram. So the list really goes on in terms of what JavaScript is not only capable of, but what it is used for. Now, JavaScript is what can take what we might consider to be a static website and make it dynamic. Bear in mind, these terms have different meanings depending on what you're referring to. But in this regard, I'm talking about a static website, meaning just simply a document that doesn't need to respond to user input. As an aside, though, there are some user interactions that we can handle with CSS, such as changing the color of something like a button whenever maybe a user hovers over it or clicks on it. Simple style changes like this would still kind of render the website as static, or at least it should be. Now, the lines do get blurred more so with what is static and what is dynamic. But as I said, we're not going to go down that rabbit hole for now. But as you continue to visit websites, I'd encourage you to start questioning whether you think the website you're on is static or dynamic. And maybe even think about how JavaScript might be powering some of the interactions on that website. Now, of course, if you're new to programming, I'm not expecting you to know exactly what's going on. But, if you're able to view a website with that kind of analytical mind towards how it has been built, you'll start to kind of find sources of inspiration with every website you visit. You might even start to notice things that just don't work properly or as well as they should. And you might start to understand why that is. It could be that there's a bug in the code that's been written, for example. Okay, so we're going to move on beyond JavaScript now, and we're going to talk a little bit about the tools that we need. So we know what ingredients we need, HTML, CSS, and JavaScript, but what about the tools that we use? Well, as you can imagine, we're going to need a computer. We'll also need an internet connection. Now, you don't necessarily need that connection to write code, but you'll eventually need it when it comes to putting your code on the internet. And the third thing we're going to need is some software to write the code. Now, just like how a writer might use something such as Microsoft Word to write a document, a coder will more often than not use an IDE to write code. Now, IDE stands for Integrated Development Environment, and is just a nice way to say a piece of software that is designed specifically for programming. Just taking another sip of water. So that usually means that, with IDEs, they'll provide additional tooling to help you program. They'll know a lot about the type of language that you're writing and can help you write in that language. For example, just like how writing an application or writing something in Word, Microsoft Word will give you the kind of squiggly red line underneath an incorrectly spelled word. An IDE would do something similar if you've used incorrect syntax, such as, like you can see with the example that we've got on the screen, where we've got this opening div tag, but we haven't got a closing one afterwards. Now, when it comes to structuring HTML, CSS, and JavaScript, we can either kind of bunch them all together in one file, or we can split it across three, having a single file for each language. Both approaches, though, as you can see, have an index.html file. Now, with our first approach, we'd simply write our HTML, CSS, and JavaScript inside of that file, likely separated with certain HTML tags. For example, our CSS would appear inside of a style tag. Our JavaScript would appear inside of a script tag. And this approach might be okay if we're just writing kind of like a little bit of CSS or JavaScript, but it can become unruly if we plan to write a lot of either. So for the sake of modularity, we'll usually take the second approach and split them across three files. This typically leaves us with index.html, style.css, and script.js. And these names are, convention rather than compulsion. Although in the case of index.html, naming it so actually does serve some purpose when it comes to how servers typically retrieve pages. Now, I've kind of skipped ahead one slide, but as you can see, let's imagine that we had a folder on our computer. Let's call that folder Supercool website. That's going to be the name of the website that we're going through at the moment. Inside of that folder, we're going to create our three files: index.html, style.css, and script.js. Now, although they're in the same folder, there's no connection between them yet. So inside of index.html, we'll create links links to our style.css file and our script.js file. We do so by creating HTML tags that reference the actual location on the computer relative to where that index.html file is. Obviously, in our case, they're all in the same folder. Now, once we've created those links, then those files will begin to work in tandem. And what we mean by that is, if you put some style in the style.css, it will impact on the code that you've got inside of the index.html file. Okay, so by this point, we should now know what a website usually consists of. HTML as a minimum, but may also include CSS and JavaScript. Now, for those files to work together, we need to either place them all together or create links between them, which kind of, as we've said already. Although some of you may not know how to write CSS, HTML, or JavaScript at the moment, hopefully you have a little bit of an understanding of at least what they are used for and why they are useful. So let's just fast forward and imagine that we've now created our super cool website. How do we put it online? Or better yet, how do you upload a website? Just going to take another sip of water. And so far, is everybody managing to follow? Or am I going too fast for some people? Okay, I've got one yes, thumbs up. Oh, and a couple. Okay, yep, great. Okay, it sounds like you're all doing good. So amazing. And Ahmed looks like he's got a pretty good answer there. So that's great. Okay, right. Amazing. Thank you, guys. So I'll just carry on. Okay, so to put a website online, you typically need a host to upload the contents of your website and a domain to point to your uploaded data. Now, when we say domain, we're typically referring to the name of the website. So, for example, google.com. Now, the goal here is for a user to be able to visit a domain by typing in its URL, such as supercoolwebsite.com, and for it to return the contents of the website. Now, getting a domain typically involves buying one. Nowadays, many hosting services will give you a domain for free, But if you want a fully bespoke one, such as supercoolwebsite.com, you'll have to buy it. Now, buying one involves visiting a domain seller such as GoDaddy. Just for the record, I don't recommend GoDaddy. I'm just using that name because I imagine many people have heard of them. Now, at the time of writing, Supercool website appears to be available, but for a bumped up price of about $1,000. Now, there are two reasons why a domain may be listed at a higher price than normal. The first is because somebody already owns that website. They've bought it pure with the sole purpose of trying to make a profit from selling it on. In my opinion, I think this is a pretty underhand thing to do. I used a worse word. I had to change it at the last minute because I didn't want to swear. But anyway, yeah, I mean, people who do this, it kind of reminds me of people who bulk buy concert tickets in a bid to make a profit from selling them on. And in doing so, it kind of, prohibits other people from buying them. Yep, as Akil said, scalper, exactly. So the second way that prices are bumped up is by the domain providers themselves, who themselves will claim that a particular domain is premium and therefore worth more than the going rate. But again, in my opinion, I think this is a bad practice because it prices many people out from just being able to buy the domain they want in the first place. You could argue that domain providers, when they kind of bump up the price, they're doing it to stop those scalpers from bulk buying. But in my opinion, nobody wins from this approach. Well, nobody is in, regular people that just want to buy the website because they want to use it. Anyway, yeah, so if you don't want to pay this premium, we can consider alternatives. You'll quickly realize that there are many variants to choose from when it comes to the suffix of a website. So besides the most common .com, .net, and .org suffixes, there are literally hundreds of others to choose from. And in fact, supercool.website is available for the going rate of about $25. I mean, you can see there they've even got a deal on where you can kind of get it for €1.18 for the first year anyway. So let's imagine that we wanted to buy this domain. That's half the process complete. So we have a domain, but we still have nowhere to upload our files. Now, domain sellers typically also offer hosting services, but let's say we have decided to host our website somewhere else, somewhere where it's maybe a bit cheaper to do so. For the sake of argument, let's imagine that we have visited Namecheap, which is a company that sell hosting and domain services. Again, not really a company I'd recommend using, but we'll move on from that. And kind of as we go through this course, I will recommend services that I use. But again, it's just an opinion anyway. So you might find that you really like any other service. Anyway, the next step is connecting our host to our supercool.website domain. So you'll hear a lot of jargon now, so kind of just get ready. And some of it might not even feel like it flows, just because there's a lot of back and forth. But just kind of, remember that it's recorded. You can watch it again, or better yet, you can kind of research some of the jargon later on. But yeah, as I've said, the process involves getting some hosting details from Namecheap, which is our hosting account, and then adding them somewhere in our GoDaddy or domain account. The details that we're typically looking for from Namecheap, our hosts, are called Dns Records. Dns Records are what you would use to set your name servers. Each domain has a name server, and name servers store the configuration of your domain as a collection of resource records. And these name servers tell the internet where to find your DNS records. So NS records point to name servers, and name servers point to DNS records. So let me just go back and let me just stop talking for a moment. So here we've got name servers here, or this is an example of a name server. And then these are 4 NS records that you can see. And then we've got an example of a DNS record, which kind of just contains lots of individual records. Okay, so DNS records are what contain the actual information that other browsers or services need to interact with. Name servers, on the other hand, help store and organize those individual DNS records. So let's just stay there actually for a moment. So if we imagine that a DNS entry is like a phone number in a phone book, the name server is the phone book. Your hosting provider will typically provide you with 2 or more name server records specific to the server. So we'll see them here, how we've got 4 name server records. And the reason why they provide multiple is in the case that one fails due to kind of redundancy or whatever may happen. So there are backups so that, you know, websites don't just drop out of the internet, or at least go down. It's probably the better way of saying it. Now, when you update your name service for your domain name, you're effectively updating every DNS record you've associated with your domain at once. Individual DNS records, such as CNAME, AAAA, or MX records, are used to map domains to specific IP addresses. This is what associates your domain name with, for example, your host or an email service provider. You know, so the reason why I highlight this is because it's possible, for example, for you to set up your email provider with one company, but your website domain with another, because it gives you the opportunity to kind of individually connect them wherever you want. An A record is a specific type of DNS record that points to a domain, an IP address, so usually a hosting provider. And as you can see, the A in A record stands for address. Now, let's just stay with that. Actually, no, we'll go back a moment. An example of an A record would be example.com, which points to an IP address of 93.184.216.34. I think I had a slide for that somewhere, but maybe I've lost it. But the reason why I wanted to highlight this is when you visit example.com, your browser asks for a nearby DNS server, and it's asking to see if it has the IP address for example.com. If it has that IP on record, it's going to send it back to your browser. But if it doesn't, it's going to tell the browser where it can find another DNS server that will have that information. So if a website is just an easy way of remembering an IP address, does that mean that you could just type in the IP address instead of the domain? And the answer to that is kind of, well, sometimes you can and sometimes you can't. So IP addresses are usually either dedicated or shared. And if you have a dedicated IP address, you can access the website by typing its IP address into the browser. For example, if you type 52.4.235.80, you're gonna end up on the wwe.com website. Whereas most websites, typically smaller ones, are going to have a shared IP address. This isn't a bad thing. It's perfectly normal to have shared IPs. Having a shared IP address is almost kind of like living in a house with other websites. So the IP address is kind of like the address for the home. Now, the reason why I wanted to use this kind of house terminology is if you imagine you were sending a letter to a house, but you didn't put a name on it, you know, as long as there aren't any postal issues, that letter is going to arrive at the house. But we're not going to know who it is actually for in the house, whether it's for your partner or someone else. But if you put the person's name on there, then it's going to find its way to the intended recipient. And that's kind of why we end up using domains such as example.com or supercool.website instead of just putting the IP address in. But as we've said, in some cases, you can just put the IP address in and it's going to work. Okay, so when you specify a website such as example.com and the server knows how to handle the request, host it's intended for and kind of which site to serve back. But you know, and then typically once you've kind of set up those MX records, those A records, and so on, it then has to, a process goes on called propagation, where it basically updates effectively every single server in the world. And it will do some of these faster than others, but typically it will take about up to 48 hours for everywhere to be updated. That's why for anyone, you know, who maybe has updated kind of the hosting records before, but maybe has noticed that either the website's not updated straight away, or maybe it's updated for you but not for others. It kind of depends on which server that your browser is requesting it from. Okay, so once your records have propagated, you should now be able to visit, say, Supercool website, and you should be able to see the website. So that means we've got our domain and we've got a hosting which is pointing to our supercool.website. Okay, so that brings us up to the third point. I'll just kind of stop again for a moment. I just want to make sure you're all kind of more or less understanding where we're going so far, and if everybody can still hear me okay, or whether I'm kind of too loud or anything. Does anyone feel like their head's spinning a little bit from hearing all of those random terms?
I think I'm good.
Okay, I'm just going to mute everyone again. So that was just to type in, but okay, that's good. It sounds like some people are saying slightly, some are okay. Hafiz has told me I'm too British, which is a pretty funny response. Okay, so bear with me one moment. Let me just see the time. I just want to make sure the recording's okay. Yep, let's keep going. So we're on the home stretch now. We're talking about how do you visit a website. Now, some of the things I'm going to talk about kind of already bled in from the previous section. So you're going to hear some similar terms again. And that's because, you know, remember, this is a fluid thing. These aren't just really kind of like three separate things. They're all interconnected. So you know the obvious things about what we need to visit a website. So, you know, like a browser, for example, you need a browser installed on your computer. You need to open that browser, type the website in and press enter and so on. But what happens then? So your browser's first going to call a software module called the DNS Resolver. And that's configured to your computer, and it kind of, what it will do is ask for the IP address that corresponds to the URL you've entered. IP stands for Internet Protocol and is an address that is assigned to each domain on the web. As you can see there with the Google one on the right hand side, there's an IP address below it, and that basically links to Google. In the case of Google, they've got a dedicated IP address rather than one of those shared ones that we mentioned. The dedicated one means that you could just type, you know, 216.58.217.206, and it's going to lead you to Google. And there are two types of IP addresses being used on the web at the moment, and even locally by kind of internet service providers or ISPs, and you know, devices such as your home router, and they are IPv4 and IPv6. IPv4 is the one that you've probably more people have seen because it's been in existence for longer, whereas IPv6 looks a bit crazier, and as you can see, it's longer as well. Now, we originally only had IPv4. But IPv6 was developed to ensure that the web can kind of continue to expand and for new IP addresses to be assigned. So, you know, I think when the internet was originally being kind of created, I don't think anyone really anticipated that we would get to the point we have. I mean, fun fact, there are over 4 billion IPv4 addresses, but we still ran out. And that's why we needed to create IPv6, because we ran out of unique IPv4 addresses, or formerly just IP addresses. Now, each IP address is assigned to a DNS. As we've said before, a DNS is kind of like a phone book for the World Wide Web. So when you type Google into your address bar, a DNS query is performed by your internet service provider. And what it does is it's going to request the name servers associated with that domain. Of course, name servers and domains and association, all that stuff is what we kind of covered in the previous section. So that's what you do when you connect a website to a host. The mapping of those IP addresses is done behind the scenes by the server, which allows you to type a domain name in order to access it. But without DNS, you'd have to type in something like that these IP addresses to actually find the website. So DNS, or domain name system, is a core internet service that maps computers or computer names to IP addresses. And IP addresses are what internet connected computers understand and connect to. So, you know, the IP address is for the computer in a way, whereas the domain like google.com is for humans. Although there is some actual overlap where computers do need to know the name of the domain, at least with regard to shared IP addresses, which we spoke about before with our kind of sending a letter to a house analogy. Anyway, so your browsers initiate a connection to that IP address using either port 80 or port 443. The IP address signifies the server, while the port number refers to the service you want to connect with. So all web servers run by default on port 80, while port 443 is used for secure web connections. We'll come back to that in a moment. In computer networking, a port is a communication endpoint. So at the software level within an operating system, a port is a logical construct that identifies a specific process or a type of network service. Now, just like how a computer has physical USB ports for making USB connections, computers and servers have digital ports that can be used for making connections with one another. The web server processes the URL you entered and gives the control to the backend. Now, a backend is typically the part of a computer system or application that is not directly accessed by the user and is typically responsible for storing and processing data. I wanted to raise that because some of you have mentioned that you want to, get better with backend development, for example. So backend code generates the HTML page and then hands it over to the web server. The web server then finally sends the HTML page to the browser via the HTTP or HTTPS channel. As an aside, the front end typically is the part of a software program or website that the user interacts with. So when a user sends or receives data on a website, the storing or retrieval of data is handled by the backend. Now, a lot of this happens in the milliseconds, and so it's not really kind of much that you'd notice, or at least as a user, you wouldn't really notice that stuff. The backend code in a website will usually connect to a database, execute queries, get data back, contact other backend services, and then finally assemble everything into a HTML document. It's not really a discrete file that we request, but it's a dynamic resource which is kind of generated on the fly using a wide variety of different technologies and components. So your browser receives the HTML page, closes the connection to the web server, and then renders it on the screen. It will load external files such as like style sheets, fonts, images, and it will also execute any JavaScript code present in the document. I'm just going to take a sip of water. Okay, so when resources such as the HTML content of a website is requested, the server is going to also return that data if they can, but they'll also return a status or a response status code that explains the outcome. Now, the most common one we've probably heard of and experienced at one time or another is 404. Now, we know this one because it's the one we see most often. It's the one we see when a page hasn't been found. If the page is found, we might not necessarily be told the response on the page, but a successful request response will be a 200. And there are many other response codes as well. So before I go into them, you can kind of see, typically they're broken up into 5 different sections. So if you see a 300, if you see anything between 300 and 399, you know it's to do with redirection, for example. Now, as I said, there are many response codes, and there are some more common ones. So, for example, 500 means internal server error. 301 and 302 refer to a resource being moved either permanently or temporarily. And there's even this one, believe it or not, which is a 418, which just basically means I'm a teapot, which sounds like a joke. It is a joke, but it literally does exist, as in that is a response code that you can get. And that kind of brings us full circle. So in summary, websites consist of HTML, CSS, and JavaScript. HTML, CSS, and JavaScript can be included inside of a .html file, or they can be split across separate HTML, CSS, and JS files. The software we use to create a website is called an IDE. To upload a website, we typically need a domain and a host. If we buy a domain and host together, they will likely be connected. But if we buy them separately, we'll need to connect them together. And without URLs, we would have to remember IP addresses. Each domain has a name server. Name servers tell the internet where to find your DNS records. Lots of things happen when you request a website. There are many different server response codes. The front end of a website is typically responsible for presentation of data, whereas the back end of a website is responsible for storing and processing data. So that was everything in the first lesson.